Okay. So we're going to keep working on A1, A2, and I'm going to put up some questions right now because they're going to apply to what we need to be able to do. And then on Monday, A2, A3, you can continue on with A4. A4 is not posted yet. And Wednesday, finish up with some more A3, A4, whatever we haven't done. And on Friday, let's see where we are in the chapter 0. But on Friday next week, and this is in this class, in the 9:30 class, quiz in class on converting measurements. So every day next week during the support class, we're going to be doing some converting of measurements and other things. And then after that class, you'll see posted on Pearson a quiz on the first 2 sections. Just like the homework, I'm just taking a couple of questions from each one. It'll be posted on Pearson, like I said earlier this morning, and now it's at least being reported. You'll have some practice quizzes that you can try multiple times before you actually do the quiz. You'll have 2 attempts and the best of the 2 attempts, and I'll walk you through it next week before you have to do it on your own. So this is what from today to next week looks like. I'm going to post this, and it's not something you need to know by heart. If we're going to do conversions on your in-class quiz, again, quizzes are open note, you can have this out. You can have anything out for a quiz that you want. If we are doing conversions on a test, I'd let you use this. Because I don't expect you to memorize every single possible conversion you can learn.
Can it be printed or?
This would be able to be printed.
Okay.
Yeah. If anything, I might even just print it and make it one of the pages on the test. But we're not there. We're not there. Okay. Now I posted. I posted this for you on Wednesday. The 10 rules of exponents. On quizzes, you certainly can have this out. On a test, you better know it by heart. We're going to put up, right now, let's see, we've got a couple of practice. I'm on it right now. Where did it go? So working with me right here. I'm going to kind of feed this in a little bit at a time. Let's do. We're just going to work on rule number 1. Rule number 1 says if you multiply the same base, a to the m times a to the n. If you multiply the same base, then you add the exponents together. As an example, if I have t to the 3rd times t to the 5th. When you multiply, you're going to take those 2 exponents and you're going to add them together and you get t to the 8th power. You multiply the bases, you add the exponents together. So, evaluate. Number 1, 4 to the 2nd. Number 2, 2 to the 3rd. Number 3, -5 to the 2nd. Number 4, -5 to the second. Number 5. -3 to the third. Number 6. -3 to the third. Number 7. Write the answer in exponent form. So
You want it spelled? Like,
write the final answer with exponent. 6 to the
4 times 4.
those you're going to evaluate. What is 4 squared? But this I want to answer as an exponent. 6 to the second times 6 to the third. Number 8. One. Already. So at least while you're writing those down, okay, roll. Valerie Sanchez.
Next.
Jason.
Here.
Manuel Garcia. Ronnie Gill. Lemmy.
Here.
You were not here during the morning, were you?
No, I emailed you.
Okay, got it. Daniel Gomez. Daniel Gomez. Carmelito. Edith Mendoza. Michaela. Simon Hernandez. Sophia Sam. Sophia. Lee Harris. Rebecca.
Here.
Liliana. Jesus. Alexa. Elizabeth Von Hart. Jocelyn. Ashley O'Hara. Jasmine Sedas. Mary Jane Carter. Catherine Perez. Paloma Contreras. Juliana Reyes. Juliana. Jenny Fallon. Kayla Martinez. Ana Garcia. Guadalupe Mejia. Brianna Mejia. Miranda Fuentes. Miranda. Lil Tion. Fine. Priscilla Ramirez. Tima Lopez. Mario Lopez. Emma Martin. Sarah Fontes. and Lorena Buskins. Anybody not get called? What is 4 to the second? 16. What is 2 to the third power? 8. Negative 5 squared.
Negative 25.
Negative 25. What is negative 5 squared?
25.
Positive 25.
No. Okay.
What is negative 3 to the third?
Negative 27.
Negative 27. What about parentheses? Negative 3 to the third.
Awesome.
Negative 27.
Negative 27.
Oh.
Okay, here we go. Rules of exponents will make or break. You cannot make them up as you go along, and you better remember the rules involving the negatives. When the cases are the negatives, and the most important part is there a parenthesis? Is there a parenthesis? Because when we see 4 to the second, that's 4 times 4. You get 4 times 4, 4 times 4, 16. It makes sense. When you see 2 to the third, you know how many times I'll see 2 to the third and I get an answer of 6. And I understand why. Because you see a 2 and a 3, you make a 6. First of all, I also see this. When you write this down, if you're not clear about what you're writing, you'll see that. It's a 23. Or maybe it's 2 times 3. It doesn't look like 2 to the third. Mathematical notation is very specific. Your handwriting has got to be very detailed and at least a little bit on point. You're going to make mistakes. Don't let the mistakes vary. Let the mistakes be mathematical, not because you're being messy. When you have an exponent, that's called a superscript. It's an exponent. It's a superscript. When you open up Pearson and you need to type in an exponent, there's a little toolbar down here, and it's got a little box and then a little box like that. That's a superscript. And when you hover over it, it says superscript. There's also going to be one that does this. It's got a little box down here. That's a subscript. The subway's down, underground, so that's down below. Subscript. Superman flies up in the air, so that's a superscript. That's where exponents go. A subscript is when you're marking elements in a progression or a sequence. T sub 1, that's the first term. T sub 2, that's the second term. And you're listing terms in a sequence or ordered pairs. Here's my first term, here's my x coordinate, there's my y coordinate for the first term, or first pair, and then I have a second point, x sub 2, y sub 2. There's the first point of the graph, there's the second point of the graph. How do I know? I said x sub 1, x sub y sub 1. This is the second one. It's labeled. It's a way to keep track of who's who. It doesn't mean you do anything with the x and the 1 or the y and the 1. But it's, hey, this is the first one, this is the second one. But when it's an exponent, 2 times 2 times 2. So that gives us 4 times 2, which is 8. And then it'll all come straight forward. This is going to be a battle. Because this is something that's going to be wrong if you don't pay attention to parentheses. And if you're lazy about putting parentheses when it's needed, it's going to be a battle. I've got a lot of things in my will about what I want on my tombstone. One of the things I think I need is going to be please put parentheses around my name. Parentheses. The negative is not being squared. The only thing being squared is the 5. If I wrote this out, it would be a single negative and then 5 times 5. Compared to this, when you have a parentheses, what's being squared? Negative 5 is being squared. So this is negative 5 times itself. So this is a single negative and you're squaring the 5s. That's why it's not positive. You have a negative and then 5 times 5, so you have a negative 25. Here it's a negative times a negative, that's positive. 5 times 5 is positive 25. That's the difference. Is there a parentheses or not a parentheses? There's no parentheses. So it's a single negative, and then you have a 3 times a 3 times a 3. So you have a single negative, 3 times 3 is 9, and then times that last 3, and 9 times 3 is a 27. So it's a negative 27. Here the negative is being raised to the third. So you have 3 negative 3. The first two, that's a positive 9. Negative 3 times negative 3, positive 9. And then times this negative 3. Positive 9 times negative 3, that's a negative 27. So now let's compare. We raised a negative to a 2, and then this form, negative to a 7. Then we did a negative to a 3, and then this one, negative to a 3. Over here, we got two different kinds of answers. We have negative 25, positive 20. And over here, when we did a power 3, they were both negatives. Can we make some kind of conclusion?
All the products coming through.
If you raise a negative to an odd power, it's always going to be a negative. And if you raise a negative to an even power, it's going to be a positive. Exactly right. Here's the rule. It's like having a little brother or sister, and they're trying to go out on a date, and they want to tag along, so you have 3. Okay, party's over. But if it's just you and your partner, well, that's 2. Positive. Okay, third wheel, negative. Or then you had double date, everybody's got a partner, positive. Then you get that 5th wheel. And I thumb, negative situation. Okay. So if you have a single negative to the first, well, that's just going to be negative. But when you have a negative to the second, in parentheses, you have a negative times a negative, you get a positive. When you have a negative to the third, the first two, negative times a negative, that's a positive, times the last negative, makes it a negative. When you have a negative to the 4th power, the 4 negatives, so those two make a positive, and those two make a positive. Positive times a positive equals a positive. So here's the rule. And it's got to be in parentheses. We've got to consider these things. If you have a negative to an even power, it's going to equal a positive. Because you're going to be able to make groups of 2. Every group of 2 negatives is going to be positive. You're gonna be able to make pair. It's an even power. If you have a negative to an odd power, that's gonna equal a negative F. So I had to do a question like, what is -5 to the 6th power? So because it's a negative to an even, the answer is going to be positive. And then 5 to the 6th power is 3,025.
I have about what happens with the exponents inside of the thing.
That's what these two are. Exactly. So they're inside the parentheses. A negative to an even, positive. A negative to an odd, that would be negative. Okay. If it was -5
Yeah.
to the 5th,
Oh. You're right. 3,215 is wrong, because I did it to the 5th power is 2,000.
125.
That's to the 5th power.
Oh, that's the 5th?
Yeah.
What's the 6th?
250, right? Because if that's 25, that's enough.
What's the 6th?
That should be 3,000.
Oh, it wouldn't be 3. This is the 3,000. So that's gonna be 15,675.
625.
So it's gonna be negative. Hey, this is a negative to an odd. So the answer is gonna be, that was positive about that. This one's gonna be negative, and this one's gonna be 3,125. Shouldn't use 5. But it's a negative to an odd, so I know the answer is negative, and then I just gotta do 5 to the 5th. This one's a negative to an even, so I know the answer is gonna be positive, then I just need 5 to the 6th. That's all it is. What is my answer gonna be, positive or negative? The negative is to an even, so I wanna make sure I put a positive answer. Then I just take care of 5 to the 6th. The answer is a negative to an odd, so the answer is going to be negative, and I take care of 5 to the 5th. Now, in addition to what you're going to get in terms of the rules, you already got the rules of exponents. In addition to the conversion table, you're going to get this. I know you can't read it because all the writing, but I'm going to give you a list of perfect squares, cube, 4th, and 5th power. Everything I'm always going to give you, I'm going to post on the announcements, and I'll put it in the email with your YouTube video. And you need to have all of these memorized notes. If you're going to survive in a math class like this, algebra 2 or higher, you need to know by heart. Definitely your 1s through 4s, your powers to the 5th, at least those. Your power of 5, at least 5 to the 4th. Your powers of 6, at least 6 to the 3rd. Power 7, 7 squared, maybe 7 to the 3rd. 8. 8 to the 4th isn't bad. 8 to the 3rd, definitely. Powers of 9, Powers of 10 are easy. Because if you have 10 to the first, that's just 1 0. 10 to the second, that's 2 0. 10 to the third is 3 0. And so on. So these are the numbers that mean the most to us in this class. But I'm also going to give you, hang on, I'm also going to give you this. Where you can practice and fill them out. And the ones that are darkened in, don't worry about knowing them. But I'm giving you the list all the way through 25. So you see that these are just 3 columns. So those only go as high as squares. The more you know your perfect squares, the easier things get in the class. It's like, I don't have to look at my shoes when I tie my shoes anymore. I don't have to look up 9 times 6. I know what 9 times 6 is without having to look it up or use calculator. So I'm going to post this, and I'm going to post, I've already posted the rules of exponents, and I'm going to give you this list as well. Okay, these. Six to the second times 6 to the third. 8 x to the third times x to the fourth. 9 y times y. 10 z times z to the fourth. Number 11. 4 x to the second times negative 3 x to the second times 5 x to the second. Here's where we're headed, everybody. I'm giving you some basic introduction problems, but here's the kind of question we're headed to. Simplify something that looks like this. Simplify something like a fraction that looks like this. Simplify a fraction inside of parentheses that's raised to a power that has fraction exponents. Well, we've already done something like negative 8 to the second. Okay. Simplify exponents that have variables in it. Now, again, I promise I'm never going to use this phrase when you ask me a question. But I'm going to use it right now. You're supposed to know this already. But if you ask me a question, I'm not going to say, oh, you're supposed to know that already. I'll explain. But this is the stuff that we're supposed to already have. I want to make sure we cover it so we have it. I'm not just going to give you a quiz and say, oh, I hope you guys remember it. That's why this is important. So we're just getting started with food. Contrary to what my wife believes, there is a method to my maths. What is 6 to the second times 6 to the third in exponent form? Thank you. Yes. 6 to the fifth. I don't want to jinx it, but I am going to give you the wrong answer that I see all the time. I will see 36 to the fifth. Because all of a sudden, 6 times 6, I know that, 36. Oh yeah, I got to add the exponent. So they jump at the part to do 6 times 6. And then, oh yeah, I got to add the exponent, so they do both. The question is, look at this problem. It is 6 times 6 times 6 times 6 times 6. How many 6s are being multiplied together? 5 of them, so it's 6 to the fifth power.
36 to the fifth would look like 5/36. And we don't have that. That's why it's not 36 to the fifth. All you do is add the exponents. So it's x to the third times x to the fourth.
So
X to the seventh. 3 plus 4 equals x to the seventh. You add the exponents. Y times y.
why?
Why is this?
Y to the seventh. All right. If I just gave you the number 3, 3, what is that? 3 to what power would give me just a 3? 3 to the what power?
What?
3 to the first. There's a 1 here, but we don't put the 1, we don't write it as an exponent. We would simplify 3 to the first, that's just 3. So this y really has, there's a 1 up there. But you simplify y to the first is just 1. But for the sake of the rules, this is y to the first times y to the first, and you're supposed to add the exponent, 1 plus 1. 1 plus 1 is y to the second. And when you write an exponent, it is how many things are you multiplying times itself? I have 2 y's being multiplied together, so that's y to the second. What you've probably been told your entire life up until now is how many y's are there? There's 2 of them, so it's y to the second. But the reason why is because you're adding exponents every single time. There's a 1, there's a 1, you just don't have to write it. So over here, z times z to the fourth is z to the fifth. Because there's a 1 right there. So that's z to the 1 plus 4, and that's how we get z to the fifth power. These rules of exponents are going to save you the trouble of writing it all out. If you did this without the rules, you would go, all right, there's a z, and then I have 4 more of them. Man. One, two, three, four. I got to write them out so I can count them up. Okay. Does anybody have an answer for the last?
4 times 3 times 5 plus 6.
Well, what is the 4 times negative 3 times 5? Should be able to simplify that as well. Negative 16. X to the
6.
6. Okay. Here's the rules of order of operations. You're supposed to do what's in the parentheses first. Well, 4 times x squared, there's nothing else you can do. That's simplified. So I could just drop the parentheses. That's a 4 times an x to the second. Negative 3 times x to the second. I can just drop the parentheses because that is simplified. So I have a negative 3 and I have an x to the second. 5 times x to the second. That's simplified. You can't do anything in there. So I can just drop the parentheses. So that's just equal to a 5 times another x to the second. Now, if you notice, when I brought out that negative 3, I put it in parentheses. So I know that the negative is still there. If I don't put it in parentheses, I'm going to think I'm subtracting. And I'll forget that I'm supposed to be multiplying by that negative 3. Even if you put a little dot to remind you that you're multiplying, if you don't put the little multiplication dot big enough, you're going to forget. Parentheses will save you. Now, there's something called the commutative property. I can rearrange them. A times B is the same as B times A. I can switch things around. I can trade places. So I can get the 4 times the -3 times the 5 all in a row. And I can multiply these coefficients together. And then I can multiply an x squared times an x squared times an x squared. A positive times a negative, 4 times it's -12. And then times that 5, -12 times 5, -60. And then this is, add the exponents, that would be an x to the 6, 2 plus 2 plus 2, 2 plus 2 plus 2, that's x to the 6. Now I'm writing out every single little bit, tiny little step. The goal is to look right here and go, all right, multiply the coefficients, 4 times -3 is -12, times 5, -60, and then I add the exponent. Square plus another 2, so another 2 makes x to the 6. You can go straight to there. But how do you get there? Everything I showed you in between. If you aren't seeing how that works, if you still would get the wrong answer, for practicing getting the wrong answer, then hey, what do you have to his hands? Okay. So we're just going to look at the homework now. And again, the Pearson homework is review. So we're going to kind of walk through these review questions. This question is asking us, choose the set of numbers that matches the following description. The description is choose the set of numbers that are integers only. So we have whole numbers, sorry, counting numbers and natural numbers. Counting numbers start with what? Naturally start with what number? 1. 1. The whole numbers can't have the word whole without O, so the whole numbers start with 0. 0. And then we learn how to spend more than we have. That's the negative number. So negative numbers are where the integers come. The integers are everything except fractions or radicals. So the positive and negative whole numbers. So this doesn't have any negative in it. So this is not our integer. X cannot be represented as a quotient of 2 integers. Well, can't be represented by if it can't be represented by integers, then it can't be the integer. That like cancels out the whole definition to begin. And then look at it. From the left, you have negative, negative, -3, -2, -1, 0, 1, 2. This has given us all the positive and negative whole numbers. That looks good. This is just the natural numbers. There's no negatives here. Irrational. Ratio. This is fraction. Again, fraction. Integers don't have fractions, so the answer is C. If you're stuck on that, you can go to the textbook and you can open it up. Go right here, and it should tell us. Wow, it used to be able to tell us right where the whole thing was. Guess you gotta type in the concept. You type in the word English. Final check. Rational numbers. The key word in rational is the word ratio. Our number system goes natural, which starts with 1. There's no 0, they're all positive. Then the whole numbers start from 0, no negatives. Then you have the integers. So that's from negative infinity to positive infinity. And then you have fractions. What's in between the integers? Those are the rational numbers. So that's any number that can be written as a fraction. In other words, any decimal that terminates or repeats. Any terminating or repeating decimal. What is a terminating decimal? What does that mean? It has an end. There's a last digit. So if I have a terminating decimal like 3/4, that is exactly 0.75. There's a last digit. But if I have something like 5/9, that's 0.5555. It repeats. It's a repeating decimal. So if it's a repeating decimal, it's a rational number. If it's a terminating decimal, it's a rational number. Any number you can write as a fraction. The number 12 can be written as 12/1. That can change that into a fraction. So all of the natural numbers are rational numbers. All of the integer and the whole number, they are all rational. So that's how the family of numbers, basically evolved. Every natural number is also in the set of whole. All of the whole numbers belong to the integer, and all of the integers belong to the rational. So the rational encompasses everything here. And then what about the ones that can't be written? Well, if these are rational, those would be irrational. Like square root 11. Square root 11 is not an exact value. It's never going to have a last digit. It's not going to repeat itself. So that is not rational. But negative 18 is. What's the square root of 1? What times itself equals what? 1. So I can change that and simplify and get a 1. That's rational. Is that a fraction? Yeah. So that's rational. Is that a fraction? Yeah. So that's rational. Is 0? Can I change that into a fraction? No. Yeah. 0 over any number. 0/5, that equals 0. 0/20, that's a 0. 0 over negative 0/1,000, that equals 0. If it's a whole number, it's also rational. Everybody up here is also red. Does this repeat? If it repeated, you'd have a bar somewhere. There's no bar over any digits repeated, so it's not repeated. You see the dot, 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 the ellipse? That means it keeps on going, so there is no last digit. So this is a non-terminating, non-repeating decimal, so that means it's not rational. So this is no. That's a terminating decimal, that's the last digit. Or that's basically it terminates. So all of those are rational numbers. You want to check all that apply. And then the rest of this section is, and this is what you're going to see on the table for the Pearson Physics Friday. Which one's bigger, -12 or -15? -12. So in here, I use the toolbar and I'm going to put greater than. And you're going to fill in the blank. So remember, hey, time out, everyone, hang on. Don't make me keep doing during recess. That's not recess. Okay. First of all, class ends at 10:40. Now you may be tired of hearing my voice, but it is incredibly rude, but I'm still going. Just start pulling and pack things up. Because I don't want to retaliate and say, I'm just going to wait until everybody just starts packing things up, and then I'll put up, hey, and then we're also going to test on this on Monday. I don't want to do that because that's not me, but it's rude. I get it. I wish I could start packing them too. But you've got to understand. But I also got to get through this information. I'm trying to help you understand exactly what you have to deal with. I want to make sure you do well. And I'm trying to talk over you guys right now. So, please. I'm still trying to talk over you right now. If you want to get out of here at 10:45, I promise I'm going to stop at 10:45. So I don't have to have this little conversation anymore. But you gotta just wait. Please. You're in college now. You're in college now. Now, I told you earlier, you don't want to be here. You have to be. So, out of respect, we're done at 10:45. If you want to leave early, then leave at 10:30. Then at least I can finish up the things I need to finish up. Because I'm going to tell you stuff that you need to know for next week or for the, tonight or whatever. As I was going to finish before you took this break, don't forget you need to do that homework 0. The get to know your homework for the Pearson, because that has a due date of Monday. Everything else is due the day of the test. But that homework 0, are you registered in Pearson and getting to know Pearson, working through the problems? Let's do them. Now you can get out of here. Have a nice weekend. You say, well, repeat at it. I'm going to do that today. Okay.
Yeah.